My cross-section shape is a square, and you find that by doing f of x minus g of x. And in order to find a side length, you do that squared. And from there, you do it for each single slice to find their overall area between each individual thing. In order to find the volume, you would take each area of the splice and you do the interval of 0, say you're doing this splice, 0 to 0.384, and then you do the area and on the inside, and that equals your volume for this slice, and you do it for each individual volume. To find the volume of the overall, not estimated, you would do the interval from 0 to 3.834. Riemann sum is the estimated value of delta x, which is change in x, multiplied by each y coordinate squared. And since you have 5 different y coordinates, you would have 5 different values, and then you multiply that all together and you get estimated value.
Okay, so my shape was the right triangle, so I assumed that both sides besides the hypotenuse were about the same, and the hypotenuse is pretty much laid across the area between, the area between the top function and the bottom function. So in order to find the volume, pretty much what I did is I used the 0.5 multiplied by the y coordinate of f of x and y coordinate of g of x. Those are subtracted from one another. Square that and multiply it by 0.525, and you get the area for each section. For the volume, however, you would do the same thing by multiplying it by 0.25. However, you take the integral from the x difference of each section. So when you do that, you'll get the volume of each section. And when you add all that together, you will get approximately this number, which is 12.04715,446. Now, if you can't take the volume of each section and you want to do it as a whole and approximate it as if it were all like infinite many right triangles, you would just take the integral. You do the similar thing where you do 0.525 multiply the integral of 0 to 3.834. When you do this, you're going to get about this number. Now, to avoid doing anything with integrals, you can also take a Riemann sum. You take the delta x, which in this case is 0.7668, divided by 4, since this is the right triangle that we were discussing about. And these values here are the change of y's when you do the top function's y minus the bottom function's y. And you square all of those. So once you do that, you're going to get about this number.
Let f of x equal sine x and g of x equal x squared minus 4x. The base of a solid is the region bounded by f of x and g of x on the interval 0 to 3.834. The cross-sections of the solid consist of equilateral triangles perpendicular to the x-axis. The area of each cross-section can be evaluated by finding r of x, which equals f of x minus g of x, then squaring r of x and multiplying by square root of 3 divided by 4. The volume of the solid can be approximated via midpoint Riemann sum. 5 sections all of equal width perpendicular to the x-axis. One can find the area of the cross-section by in the middle of the range and then multiply it by the width of the section. Adding them up will give an approximate volume. The actual volume can be found through calculus. Since all the cross-sections have areas that can be found by A equals square root of 3 divided by 4 times the square of r of x. If the sections are infinitely small and added up, the volume of the solid will be
semicircles. And I used 5 different sections for the semicircles. The diameter was the area between f of x and g of x, and I said that let r of x represent the diameter. In order to figure out an approximation using these 5 shapes, I needed to divide them in equal, we would call width, I guess. 0.7668. That's the width. In order to find the area of a slice, I square the diameter, multiply it by pi divided by 8. Now to find the volume, all you have to do is multiply that by the width, which is, like I said before, 0.7668. And so I found the volume for each of the slices right here. Then I summed them all up. Now, in terms of calculus, I basically just took the integral from the first intersection 0 to the second intersection 3.834. And then since we're talking about semicircle, you have to put pi divided by 8 in the front, because this would be the diameter squared and this would be pi divided by 8. And I got something really, really close to the thing I found using spreadsheet. Now, in terms of my Riemann sum, I used the midpoint Riemann sum formula. What I did is I took the diameter, or our y coordinates over here, and I squared them, of course, each of them, and then I multiplied them by the width and pi divided by 8, because formula for volume is using diameter is pi divided by 8 times diameter squared.
Look out the window, it's a rainbow. モノクロテレビを見てたんだ。それが今は colors everywhere, and I don't wanna be anywhere.